Good morning, students. Today we will discuss about addition and subtraction of scientific notations and remaining mathematical operations on scientific notations as well as significant figures. So first I will start with addition and subtraction of scientific notations. So first example, see, I have given two numbers, 2.5 into 10 power 4 plus 5.5 into 10 power 4. So in these two numbers, exponential form is same, that is 10 power 4. So when exponential form is same, then you can group it. So here 2.5 plus 5.5 directly you can add into 10 power 4. So 2.5 and 5.5 we can write 8 into 10 power 4 or 8.0 into 10 power 4. Next example. So I have given two numbers, that is 5.25 into 10 power 2, 2.0 into 10 power 3. So here if you see, exponential forms are not same. 10 power 2, here 10 power 3. So before adding, so the condition is we should make exponential forms same. So you make it same. How to make it same? So whether you have to convert 10 power 2 into 10 power 3 or 10 power 3 into 10 power 2, anyone you can change. So now here if you want to change, so I kept first number as usual, second number I have changed. What I did, I have reduced 3 to 2, means 1 unit I have reduced from exponential form, means power I have reduced to 1 unit. When power is reduced to 1 unit, then this decimal point you have to move towards right side. So remember, power is reducing means decimal point will move towards right side. Power is increasing means decimal point move towards left side. So we got 20 into 10 power 2. Now exponential forms are same, that's why group these numbers, 5.25 plus 20 into 10 power 2. So this is 25.25 you will get into 10 power 2. But 25.25 is not scientific notation, because you know scientific notation means capital N value into 10 power n. This capital N must be 1 to 9. So here 25 is not between 1 to 9. So if you want to convert the final results into scientific notation, so you have to move this point towards left side. So if you move that point towards left side, you will get 2.525 into 10 power 3. This is the final answer. Next example, this time I have taken a negative powers. So 2.5 into 10 power minus 2, 4.5 into 10 power minus 3. So here 10 power minus 2, 10 power minus 3. What is condition? You have to make the exponential form same while adding or subtracting. So now this is 10 power minus 2, I kept exponent same, but I have changed this one. So I said if you move decimal point towards left, then you have to add 1 unit to power. So if I add plus 1 here, if I add plus 1 here, minus 3 plus 1 becomes minus 2. So 0.45 into 10 power minus 2. This is 2.5 into 10 power minus 2. Now we can group these numbers. So 2.5 plus 0.45 into 10 power minus 2. So answer is 2.95 into 10 power minus 2. The result is in scientific notation. Next, this is about addition and subtraction. We'll go for multiplication and division. So I have taken this number, this is the division, 2.5 into 10 power 4 by 5 into 10 power 6. So first we will separate exponential forms and numbers. 2.5 by 5 into 10 power 4 by 10 power 6. So 2.5 by 5 means exactly 2 times. So 1 by 2 into 10 power 4 minus 6. This 10 power 6 will become 10 power minus 6. So when bases are same, we can add powers. So 4 minus 6. Next, 1 by 2 means 0.5. 4 minus 6 means 10 power minus 2 you will get. So if you want to write in scientific notation, just you have to move this point towards right side. When you are moving point towards right side, you have to add minus 1 to the power. So 5 into 10 power minus 3 is answer. Next, example 2 regarding multiplication. In multiplication, directly you can group the numbers. So 5 into 4 and 10 power 3 into 10 power 4. So 5 into 4, 20, 10 power 3 into 10 power 4. So we can add powers 3 plus 4, that is 7, 10 power 7. So we can write the answer in scientific notation by keeping point here 2.0 into 10 power 8. Means point we are moving towards left, that's why power increases. Moving towards right means power decreases. Remember. So this is about scientific notation, addition. So all mathematical operations. Next. So now we have seen, just now we have seen mathematical operations on scientific notations. Same mathematical operations on significant figures. Both are different. Don't confuse. These are significant figures. Those are scientific notations. So addition and subtraction of significant figures. Here rule. The result cannot have more digits to the right of the decimal point than either of the original numbers. That is the rule. So here see example, you can understand easily. I am adding these three numbers. 12.11, 18.0, 1.012. If I add all these numbers, so I got the result 31.122. So this 31.122 has how many significant figures? There are 5 significant figures. But what is the rule? The result cannot have more digits to the right of the decimal point than either of the original number. So if you take first number 12.11, after decimal point there are 2 digits. If you take 18.0, after decimal point there is a 1 digit. So if you take last number, after decimal point there are 3 digits. So you have to consider 18 because it has least number of digits after decimal point. So here 18.0 has only 1 digit after the decimal point, and the result should be reported only up to 1 digit after the decimal point. So which is 31.1. So answer is 31.1. So here we got 31.122, but you have to remove this 2 because after decimal point there must be a 1 digit. So what is the answer? 31.1 is the answer. Next, multiplication and division of significant figures. In these operations, the result must be reported with no more significant figures as in the measurement with the few significant figures. So means, see, I will explain same thing through example, you can easily understand. So we are multiplying here 2 numbers, one is 2.5, another one is 1.25. So among these 2 numbers, means among 2.5 and 1.25, which number has the least number of significant figures? The result also must contain that many significant figures. That is the rule. So since 2.5 has 2 significant figures here, so the result should not have more than 2 significant figures. Suppose if I take 2.5 0.55 into 1.256 into 2.1234. Suppose these three numbers I am multiplying means the result must contain three significant figures. Why? Because so in these three numbers, which number has less number of significant figures? That is 2.55. So that's why the result also must contains three significant figures. Next, so in this example, what is our answer? 3.125 is our answer, but the answer should contain only two significant figures. That's why you have to remove two digits from the result. So we'll get 3.1 is the answer. Next, see here, if you want to reduce number of digits from the result, we should follow some rules. The process is called as rounding of the numbers. So here simply you should not remove the see 3.125. I have removed 5 and 2. So there are some rules. We should not remove simply. We should follow the rules while removing numbers from the results. So that process is called as a rounding of the numbers. So there are three simple rules. So just you see, if the rightmost digit to be removed is more than 5, the preceding number is increased by 1. Suppose this is our result. For example, this is our result. From this result, I have to remove last digit. What is the last digit here? 6. If I want to remove 6, we have to check whether last digit is more than 5 or less than 5 or exactly equal to 5. If it is more than 5, the preceding number we have to increase it by 1 unit. The preceding number here is what? Your preceding number is 8. We have to increase it by 1 unit, means that 8 should become 9. So what is our answer? 1.39. So very simple. If last digit is more than 5, then while removing that last digit, we have to increase the preceding number by 1 unit. Next, if the rightmost digit to be removed is less than 5, for example 4.334, so what is last digit? That is 4. If you want to remove 4, you no need to change the preceding number. Just as usual you can write. Directly you can remove if it is less than 5. Last number is less than 5, you no need to change the preceding number. So 4.33 is your answer. Next, so if it is more, we have to increase the preceding number. If it is less, no need to change the preceding number. If it is exactly 5, so if it is exactly 5, if rightmost digit to be removed is 5, then what is the condition? Then condition is the preceding number is not changed if it is even number. The preceding number is even means no need to change, but it is increased by 1 if it is odd number. So now you see this example. Suppose 6.35 is our result. I have to remove 5 here. If I want to remove 5, so preceding number you check. Preceding number is 3. That 3 is odd number. When it is odd number, you have to increase by 1 unit. So our result will be 6.4. So 6.35, I am removing 5, but preceding number is 3. So when it is odd number, I have to increase it by 1 unit. So answer is 6.4. Similarly, if you see 6.25, from 6.25, I am removing 5. So preceding number is even number, so no need to change even number. If it is odd number, you have to increase. So these are the rules for rounding of the numbers. Next concept, Dalton's atomic theory. So important theory for board exams. So even in competitive exams also they are asking questions. So last JEE exam they given one question on Dalton's atomic theory for 4 marks. So what are the important postulates of Dalton's atomic theory? So this is a very old theory, starting theory. about atoms and molecules. So John Dalton proposed the atomic theory in the year 1808. This is the 18th century. So the postulates of the theory are, first one is, matter is made up of indivisible particles known as atoms. According to Dalton's, atom is an indivisible particle. After that, there are many advanced techniques came and they proved atom can be divisible into different particles. Atom contains electrons, protons, neutrons. There are more than 100 subatomic particles in the atom. So like that there are, see, that is a modern theories. So according to Dalton's, atom is indivisible particle. Next, all atoms of a given element have identical properties, including atomic mass and atomic size. Suppose if you take any element, for example, element means iron if you take, or hydrogen if you take, all iron atoms having identical properties. Atomic mass same, atomic size same, everything same. So if you take hydrogen atoms having same size, same mass. But according to new theories, there are isotopes like 1H1, 1H2, 1H3. These are isotopes. So in case of isotopes, mass numbers are different for same element. So that is one of the drawbacks for Dalton's atomic theory also. So here these are old theory. So by that time these are the postulates. So identical properties, including atomic mass and atomic size. Next, atoms of different elements have different properties. So different elements having different properties. Like hydrogen, oxygen, if you take, these atoms having different properties. Next, compounds are formed when atoms of different elements combine in fixed ratio by mass. Yes, when elements are combining in fixed ratio mass, then you are getting compounds. So this is one example. So 2H2 plus O2 gives 2H2O. Next, chemical reaction involves a reorganization of atoms, and these atoms are neither created nor destroyed during chemical reaction. So these are the postulates of Dalton's atomic theory. Next, important concept, what is atomic mass? So atomic mass means, we know, mass of one atom of any element is called as atomic mass. Then in olden days there are many scales to represent atomic mass. So suppose if you take any atom, it's very small. We can't see the atoms also. Then how to measure atomic masses of atoms? So nowadays there is a technique, mass spectrometry. It is a device. So through that device we can calculate atomic masses of any element. Even one atom weight also we can. So but measuring all atoms weight by using the devices is difficult. That's why they have introduced some scales. By using these scales we can compare one atom weight with another atom's weight. So one of the popular scale is carbon-12 scale. Carbon-12 scale means by comparing with the carbon-12, they have explained about atomic masses of other elements. So according to this scale, atomic mass of any element equal to mass of one atom of the element divided by 1/12th mass of one atom of C12 isotope. Here 1/12th mass of one atom of C12 isotope value equal to 1 AMU. So we can say 1/12th mass of carbon-12 isotope, or we can write 1 AMU. So 1 AMU means atomic mass unit. 1 AMU equal to 1.66 into 10 power minus 24 grams. So now, example, if you want to express atomic mass of hydrogen according to C12 scale, the atomic mass of hydrogen equal to 1.008 AMU. You are keeping AMU means that is exactly mass of one hydrogen atom. So this one we can take nearly 1 AMU. In our regular calculations, instead of writing 1.008, we will write 1 AMU. Similarly, oxygen 15.994, so we will take approximately 16 AMU. So carbon 12 AMU, we can write 12 AMU. So like this, atomic masses we can express by using C12 scale. Next, what is average atomic mass? In case of elements with isotopes, for example, you take any one compound with a different isotope. Chlorine, if you take, chlorine has two isotopes, chlorine 35, chlorine 37. These are mass numbers. So atomic number is 17, 17. General representation of element. Atomic number you will write it down, mass number you will write up. So this chlorine exists in the form of two isotopes, that is chlorine 35 and chlorine 37. Then which number you have to consider as atomic mass, 35 or 37? So in such cases, we have to use average atomic mass. So what is average atomic mass? Average atomic mass means atomic mass of element into its relative abundance of the isotopes. So summation of atomic mass of one isotope into relative abundance of isotope gives average atomic mass. Or you can write one more formula, average atomic mass equal to A1R1 plus A2R2 and so on by R1 plus R2. See, A1 is mass number of one isotope, A2 is mass number of another isotope. Here R1, R2 are abundances. What is abundance? Abundance means percentage availability of an isotope in nature. For example, in this chlorine 1735, chlorine 75% available and 37, chlorine 37, 25% available. Means if you take chlorine gas from any reaction, so if you analyze that chlorine gas, so that chlorine gas contains 75% of chlorine 35, 25% of chlorine 37. That 75%, 25% are called as abundance of those isotopes. So now we can substitute directly in this formula 75% or 25%. What is relative abundance? Relative abundance means instead of 75%, we have to take 0.75. Instead of 25, we have to take 0.25. That is a relative. So we'll see one example, then we can understand easily how to calculate average atomic mass. So now boron has two isotopes, one is boron 10 and boron 11, means boron 10 and boron 11. What is atomic number of boron? 5. So like this we can represent isotopes. And they only given percentage abundances 19.6%, means 10 is 19.6%. 80.4%, that is 11 is 80.4% respectively. What is the atomic mass of boron? So how to simplify this? Then you have to take formula, that is average atomic mass average atomic mass A1 R1 plus A2 R2. If more isotopes means you can increase the formula. R1 plus R2. So what is A1 value? So what they given A1 value? 10. A2 value 11. R1 value 19.6. 10 into 19.6 plus A2 value 11 into 80.4 divided by R1 plus R2 100. No doubt total abundance always must be 100. So if you simplify this, you will get average atomic mass of boron 10.8. So thank you.